I'm Chrissy, and today we're going to be doing an experiment. So the first thing you need to do when you do an experiment is always grab your materials. So let's go over to the materials bench and grab those materials and your safety equipment. So for this lab, some things you're going to need is you're going to need 0.2 molar of sodium thiosulfate. You're going to need 1 molar of hydrochloric acid. You're going to need a 250 milliliter flask. You're going to need 2 100 milliliters of graduated cylinders and 1 10 milliliter graduated cylinder. You're also going to need a piece of paper or a flashcard with an X on it so that way you can tell when the reaction has started. And I believe that's it. I could be wrong.
Stopwatch?
That's right. Okay, so you're going to need a stopwatch for this experiment because you need to tell how long it's going to take. So don't forget that stopwatch. Also, don't forget your safety equipment. So you're going to need your safety goggles. You can wear gloves or an apron if you would like, but don't forget those safety goggles because getting acid or sodium thiosulfate in your eyeballs is a trip to the ER and probably an eroded eyeball, which is not something you would want.
Chrissy never wears her safety glasses, ever, no matter how bad the chemical is. She could be working with hydrofluoric acid, and she still wouldn't wear any safety equipment. And hydrofluoric acid is the stuff they used in Breaking Bad to melt the body, like...
So now that we have all of our materials, you need to make sure that you label everything because all of the liquids that we're working with today are clear, and so you don't want to get them mixed up. So you need to designate a graduated cylinder for water, a 100 milliliter graduated cylinder for your sodium thiosulfate, and the 10 one is your hydrochloric acid. Next, you're going to draw an X on a paper just like this, and so that way when you put your flask on there, you can see it, and you will be able to determine how long that will take.
Chrissy literally never labels her stuff. She messes it up all the time. It's either never labeled or it's labeled completely wrong. Chrissy, what chemicals are which? I can't tell.
So, now that we are getting ready to actually do the lab with all of our equipment, you're going to follow this little chart. And Katie and I have linked the chart, and we will have a physical copy for you guys to see on our webpage on the Wiki Spaces, so be sure to go check out that website because it's pretty darn good. Okay, so we're going to start with the hydrochloric acid, which is 8 milliliters, and the water. So for our first one, it's going to be 8 milliliters of the hydrochloric acid, and 17 milliliters of the water, and then we will additionally measure out 25 milliliters of the sodium thiosulfate for a second later. So,
Do you want a funnel?
a funnel might be a good thing to grab, because I am a klutz. Handy dandy funnel. Goes in my handy dandy beaker.
Make sure you pull it up and out.
Yeah, I know. Thank you, Katie.
Maybe if you had actual muscles, you could.
First try. Bam, bam. Thank you, world.
So we know Jay. The final ones that Jay reacts with.
So, we have our 8 milliliters of our hydrochloric acid, and we are going to dump this into the flask.
So you know Jay.
Now, we are going to measure out 17 milliliters of water.
If there's anything you don't know.
So, I'm going to pull this out, and this is my water.
Reacts with
We don't know how to work.
It creates something. It reacts with CaCO2, CuSO4.
Perfect. So now that I have 17 milliliters of water, you're going to dump this in with the hydrochloric acid. Now, you have to make sure that you always do one chemical and your water. Because if you do both chemicals and then the water, it's already going to start reacting. So now is when we're going to measure out our sodium thiosulfate, which is 25 milliliters.
So H2O4 and zinc, it doesn't react with
So before we add this in, bring out your X again, and we are going to put our flask on this X and make sure that it's in the center. So just like this. And then we're going to start adding this, but before we do, make sure you get out your stopwatch.
Chrissy has never used a stopwatch before in her life. Does she even know how to use one? I wouldn't know. I always do it. Chrissy, you start a stopwatch?
So now, as I add the sodium thiosulfate, you're going to notice that the X is starting to disappear. And what you want to do is, the reason you need a stopwatch is because you need to know when it finally disappears. So the second that I poured it in, my lab assistant Katie, who's also our brilliant filmer today, she started a stopwatch on our computer, and so we are timing how long it takes for this X to disappear. You're going to stop the stopwatch as soon as you can no longer see the X, because this means that the reaction has come to a full stop and it has run its full course. Now, as you might notice, the solution itself is becoming more and more cloudy, and this is exactly what you want.
Yes, sir.
When you're all done,
reacting. Can you come look at it?
you are going to record your time in seconds. So as you would notice, we are like pretty much done. Like, I can't really see that X anymore. So Katie is going to stop our timer, and we're going to notice that it took about 33 seconds. So using this data, we're going to continue to repeat this experiment using this data, which is going to hold your hydrochloric acid constant and changing your sodium thiosulfate. But then we're going to repeat the whole experiment, keeping your sodium thiosulfate constant and changing your hydrochloric acid. When you're done doing that, you should notice that your data should look something like this. Whereas, our first one took about 33 seconds, and you should notice that it takes a little longer each time. We're going to use these numbers to determine the rate order.
I'm not even sure Chrissy has ever done a lab right. This is my data table.
So, in this final step of the experiment, it's to upload the data onto the spreadsheet located on the Kinetics page on the AP Chem wiki space. Just open the Excel sheet, enter the times into the correct table. Now here's the part with the most math. You're going to need to calculate new concentrations of the chemicals in the solutions after mixing. To do this, take the amount of chemicals in the mixed solution and divide it by the total amount of milliliters in the solution. This will need to be done each time and each experiment. Enter this data into the concentration tables. Next, take the natural log of the concentrations found above and enter this data into the natural log tables. Finally, take the inverse of the concentrations found and enter this data into the inverse concentration tables.
Katie, is this where this number goes?
Can you even read the chart?
This spreadsheet takes the data we entered and graphs the zero order, first order, and second order data, so we can examine it to figure out what rate order the reactants are. The graph with the straightest line is the rate order for the reaction in the rate equation. For example, based off this data, the thiosulfate is first order because the data points we had produced the most linear set of data. The hydrochloric acid is a little harder to tell, but the graph with the most linear set of data is the 0th order. This means our rate equation is R is equal to K thiosulfate times hydrochloric acid to the 0th power.
Chrissy doesn't even know what half of that means. I wrote the script for her. She just formatted it. Hey, Katie!